In today's video, we're going to be going over the advanced features of Suphi's DataStore module. Now, before you watch this video, it's highly recommended that you first watch the basics video. So let's first talk about the hidden feature of the DataStore module. So if I create a DataStore object, and I use just the name and key. And if I print the DataStore object's unique ID, so I'll say print DataStore unique ID. And if I do the same on script B, and if I run the game, we should see that it prints the same ID twice. And this is because when we use new, it will get the same object in both scripts. But if I change new to hidden and run the game again, now we should see that the two scripts have different unique IDs. So this DataStore object is not the same as this DataStore object. And if I print A in this print, and if I print B in this print, and if I do the same on this side, but instead of using hidden or new, let's use find, and let's wait, do a task wait. So we give a chance for these two scripts to run first, and then let's print the unique ID and put C here. So let's press run and let's see what happens. So we should see that script A has this unique ID, script B has this unique ID, and script C was able to find script A's object, but script C is not able to find the hidden object. So if we use hidden, it cannot be found by new or by find. One use case of using hidden is to emulate servers. So what I could do is delete script C, and if I change this to open and do the same on script B, and if I change this back to new, so now we're getting the same DataStore object on both of these scripts. If I press run, we can see that script A and script B were both successful in opening the DataStore. But if I change script B back to hidden and run again, we can see that script B was successful in opening because script B ran first and script A ran second. And because script B opened the object, script A was not able to open the object in this DataStore object. So now script A reports that the object is locked to this unique ID. Another use case of using hidden is, let's imagine that script B wants to open the DataStore to a player that is currently not playing our game. And we successfully open the player's DataStore. And let's imagine that at that exact moment, the player enters the server. Now, what would happen is this player added event will fire and we'll use the new, and this new will return the same DataStore object that we created over here. So it won't create a new DataStore object. It will use this one over here. Then we'll connect a event to the state changed event. And then we run the open. And because it's already open, this will just return success. So it instantly exit out from this loop. And let's assume that once this is all done, now the destroy function is called and the player's DataStore is now destroyed. So now the player is in the game with a destroyed DataStore. So now every time we try to interact with their DataStore, it's always going to return nil when we attempt to find their DataStore. So any DataStore calls will always fail. So this problem can be easily fixed by changing this from new to hidden. So now, when we try to open a player's data store that's currently not playing our game, it's going to create a hidden data store. Then we open the hidden data store, and let's assume that this player enters exactly at the moment that we've opened it on this script. And this script creates a brand new. Now it won't be able to find this data store object. This will create a brand new data store object. So this one and this one will be separate, and we'll connect a state change to a separate data store object, and we'll attempt to open this separate data store object. And because this data store object has already been opened from the hidden object, this open is going to return locked. So it's not going to be successful. So it's going to wait 5 seconds, and it's going to try again. Wait 6 seconds, and wait again. So now this data store is going to constantly wait until the data store object is unlocked. And once this adds the coin and destroys and unlocks the data store, now this data store object is going to be able to open and continue like normal. So currently, this script and this script no longer conflict with one another, but script B only works if it tries to open a player's data store that is currently not playing our game. What if the player is already playing this game in this current server? Well, what would happen is hidden will still return a brand new object, but when we try to open it, because it's already been opened by this script, it's going to return locked, and it's going to produce an error. So what we could do is try to find if this data store object already exists. So to do this, what we can do is, just like we did here, use the find and use OR. But instead of using this player ID, we want to use our fixed player ID. So what we're doing here is saying, try to find the player's data store if they are already on the server, but if they're not on the server, then create a hidden one. And then we attempt to open. Now, if we try to open the one that's already opened over here, this will just instantly return success. Or if we created a hidden data store, it will attempt to open the hidden data store. And if they're in no other server in our game, then it should return success. And then finally, we want to add one coin. But now we have the problem of, if we found this data store over here, we don't want to destroy this data store because we want this player removing event to destroy this data store. But if it's hidden, we do want to destroy the data store. So if it's hidden, we want to destroy. If it's not hidden, we don't want to destroy, and we want this to destroy. So what we can do is say, if datastore.hidden equals true, then we want to destroy. And now script B is going to be able to work when the player is in the current server, or if this player is in no server, where before it would only work if the player was in no server. So how would we go about making script B work if the player is online but on a different server? And that's where the DataStore module's queue system comes into place. While the queue system is very resilient, it's not 100% sound, and there are very small edge cases where messages can get lost. So if you want to be 100% secure, you're going to want to make your own server-to-server communication system. But if the data you're sending is not very important, the queue system is a good option. So before we add the queue system to script A and script B, let's disable these two scripts. So I'm going to disable script A and the script B, and let's make a new script. And let me show you how the queue system works in this script. So in order to queue data into this DataStore object, we're not required to open this DataStore object because we can queue in any state in the open, closed, or destroyed state. And to do this, all we need to do is say DataStore and call the queue function. And this function is going to take up to 3 values. The first value is the data we want to queue. So for instance, I can queue a number of 1, 2, 3, 4. I can queue a string, or I can even queue a table, like so. And for now, let's just queue a string called test. And the second value it wants is the expiration time in seconds. Now, if we don't provide a time, it's going to default to 7 days, but we can go all the way up to 45 days. But for instance, let's say we wanted this data to automatically get destroyed after 10 seconds. We'll just put in the value of 10. And finally, we can put in a priority. And by default, this will be equal to 0. But if we want this data to be processed quicker, we can increase the priority. This function will also return a response. So just like the open function, we can say equals to DataStore dot response, and it will return the success response if it was successful in adding this data to the queue. Now for now, I'm just going to use the default priority and the default of 7 days, and I'm just going to pass the string of test. I'm also going to pass a number of 1, 2, 3, 4, and finally I'm going to pass in a table, and inside of this table I'm just going to have the values of 4, 6, and 9. And I'm also going to print the response of these queues like this. And now I'm going to run the game. And we can see that all 3 queues were successful. And now I'm going to stop the game. So now we have 3 values in the queue, and these values will stay in the queue for up to 7 days. Let's now delete these 3 lines of code, and let's now process the queue. So to process the queue, 2 things need to be true. The data store needs to be open, and we must have at least one function connected to the process queue event. If we don't have these 2 things done, then the queue system is going to stay dormant and will never get activated. So let's first open the data store, and I'm going to print the response for the open. So I'm going to say data store open. And then, even though we've opened it, we must also connect a function to the process queue event in order to activate the queue system. So to do this, I'm going to say data store dot process queue connect function. Now this function is going to give us 3 values. The first value is a ID. The second value is a list of values. And the third value is going to be the data store object. So let's now just print the values array. So I'm going to say print values, and let's run the game. And we can see that it was successful in opening the data store object. And if we open up this table, we can see it has an array with 3 values in there. One is the text string, one is the 1, 2, 3, 4 number, and finally we have the table with the values of 4, 6, and 9 in them. Now if we wait 30 seconds, we should get this process queue event should fire again. So every 30 seconds, this process queue event is going to keep firing over and over again. So how would we go about stopping the event from firing over and over again? So what we need to do is we need to delete these values from the queue. And to do this, what we need to do is say data store, and we're going to use the remove function, and we're going to provide the ID. So by providing the ID into the remove function, it's going to delete these 3 values from the queue. And that's going to prevent the queue from firing again in 30 seconds. And just like the open function, the remove function will return success if it's successful in removing the values from the queue. So if we want to make sure that the remove was successful, we could just check it with success, just like we do with open. And if I now run the game, we should notice that it prints the values one last time, and then it's going to remove the values, preventing this process queue from running a second time. So let's press run. And we can see it processed the values. And this time, because we removed it, even if we wait 30 seconds, it should not print these values ever again. So these values are now removed from the queue. So now that we know how the queue system works, let's delete this script and let's re-enable script A and script B, and let's add the queue system into script A and B. So the way this is going to work is currently we're trying to find the data store, and this is only going to happen if the player is currently already in our current server, and then it's going to attempt to open. And if open is a success, which it should be already open because this script is most likely has already opened this data store, and then it's going to set the value directly to the data store that was opened by this script. But if the player is currently not in this server, it's going to create a hidden data store, and then it's going to attempt to open. Now, open can either be success, which means that the player is currently not playing in any server and it's not locked, or it can be locked. Locked would mean that it's currently open in a different server, and finally it could fail, it could error, and that means that the Roblox servers are currently having problems and it was unable to open their data store. So what we want to do is, if it's locked, we want to send a message using the queue system telling whoever locked the data store to add the 1 coin. So in order to do this, instead of checking the response directly like this, I'm going to save the response in a variable, and I'm going to say response equals data store open, and then we're going to check the response for multiple values. So I'm going to say if response is equal to datastore.response.success, then this means that the data store was successfully opened and we can instantly just set the coins. But if we can say else if response is equal to datastore response dot locked, then this means that the data store is currently open by a different server. So here we're going to send the message, and finally we're going to have else, and anything, if we get to here, this means that the Roblox servers are currently having problems and we're not able to set the value. So now I'm going to move this into this section here. So if we manage to open, we're going to increment the coins. And if we don't manage to open, I'm going to use the data store, and I'm going to use the queue function. And I'm just going to pass the value of 1, meaning that we want to add 1 coin to the coins table. And finally, if this section happens, I'm just going to print failed. And we can delete this part now, but we still want to have this hidden equals true destroyed, because if this is a hidden data store, we want to make sure that we destroy it so that we don't have a memory leak. And if we don't like using enums, we can use strings. So let's convert these to strings like this and like this. And also remember that this queue function also returns a response. So this queue may also fail. So what I'm going to say is if datastore queue is not equal to success, then print, I'm just going to print failed like we did below. Now, before we continue, I just want to explain where this can fail. So here we see we get the response of locked, which means that this data store is currently opened by a different server. And then we add the value 1 to the queue. Now, as we add this value 1 to the queue, at the exact same time, the other server may decide to destroy the data store. And if that happens, the data store on the other side will never be able to process this value until the player decides to log back into the game again. But because this value is only stored in the queue for 7 days, if the player does not log back into the game within 7 days, this coin is going to get lost. So let's now connect a function to the process queue event. So over here, I'm going to say DataStore, process queue, connect, and we're going to create a function called process queue. I'm going to say local function, process queue. And if we remember, this receives a ID, it receives an array of values, and it also receives the DataStore object. And let's pass this function into the event. And now let's loop through the values, and for every value, let's add 1 coin into the data store. So I'm going to say for index value in values do, and then I'm going to say data store dot value dot coins plus equals value. Now, there's a few ways we can handle saving this data and removing the ID, and every way has a different downside. But if the value that we're going to be adding to the data store is not very important and we don't really care if it's lost, the most simplest way is at the very top is to say DataStore.remove ID, and what we can do is say if is not equal to success, then return. So this is the most simplest way to process the queue. So we're going to attempt to remove the values from the queue, and if we do manage to remove them, we're going to add them to the data store. If we don't manage to remove them, we're just going to return, and in the next 30 seconds we're going to process the queue again, and hopefully in the next process time it should work correctly. If it doesn't, it's going to keep looping over and over again until it successfully removes from the queue. So the way this can fail is, let's assume that we successfully remove the values from the queue and we add the coins to the data store, but let's assume that after we've added the coins to the data store, that the data store fails to save in the next save intervals or when we call the destroy function. So what we could do is say if DataStore save, and we can say is equal to DataStore.response.saved, or we could use a string. So if it is successful in saving, we just need to return and do nothing, because now we know it was successful in removing the items from the list and it was also successful in saving. But if it's not successful in saving, now we're kind of stuck. So we're going to try as a last resort to add the values back into the queue. So just like we did here, I'm going to loop all the values, and then I'm going to say DataStore, and I'm going to use the queue function like we did here. And instead of just blindly passing the value 1 back, because we don't know if all the values are 1, another script may add 2 to the queue. So I'm going to pass the value back into the queue. And I'm also going to make sure that this is success. So I'm going to say if is equal to success, then we're going to remove the coin from the data store. So we only want to remove the coin if it was successful in adding the coin back into the queue. So I'm going to say coin negative equals value. And for any values that were not successful being added back into the queue and were not removed from the data store, we're just going to hope that in the next save intervals the coins get saved, or when the data store is destroyed. But if they can't get saved in the next save intervals, or when the data store is destroyed, then them coins are going to get lost. So this process queue still has a small chance of losing coins. So let me show you a different way that has a different problem. So what I'm going to do is copy and paste this function, and I'm going to comment out the old function, and let's rearrange this to process the queue slightly differently. So instead of doing it like this, what we're going to do first is add all the values into the data store. And then I'm going to attempt to save the data store before I've even attempted to remove the values from the queue. So I'm going to say if data store save is not equal to saved. So if we fail to save these values into the data store, I'm going to subtract these values out of the data store, and then I'm going to simply return. And then we're going to attempt to remove the values from the queue. We don't need this part down here, so we can delete these. So we first add the values to the data store. We then attempt to save. If we fail to save, we remove the values from the data store and we return and hope that it works in the next time that we process the queue. If it does save the data store, that means these values are now in the data store for certain. We attempt to remove the values from the queue. And if it's successful, so we make sure it's equal to success, that means we were successful in saving and removing, and we can just return and do nothing. But if we're not successful in removing from the queue, now we have the values and we still have the values in the queue, so they're going to get processed again and they're going to get double the amount of coins. So what I'm going to do is I'm going to loop through the values again, and I'm going to attempt to remove the values. I forgot to set this to negative, and this also to negative. And once we remove the values, we're going to attempt to save the data store one last time. And if this final save fails, we're going to hope that the data store saves in the next save intervals or when the data store is destroyed. So here we have two options. This option has a chance to receive double the amount of coins, and this option has a chance of losing coins. So whichever situation is better for whatever you're doing on your project, one of these two options may be better or worse depending on what you're doing. Let's now take a look at how we can compress our data in the data store. So to do this, I'm going to delete script A, and I'm going to rename script B to script. I'm going to move this script into the center, and I'm going to delete all this part here, and I'm just going to use the standard DataStore.new name and key. So let's first open the data store, and I'm going to print the response. So I'm going to say print data store open. And now I'm going to set the data store's value to a table. So I'm going to say datastore.value equals table. And I'm going to have a key called, let's just say test equals test. And I'm going to have another key called array equals, and this is going to have an array with numbers, for instance, 1, 2, 3, 4, 4, 3, 2, 1, and 9, 8, 7, 6, 5, 4, 3, 2, 1. And let's do a small number of 5. And then let's create a bool equals true, and let's also just create a num equals and a number. Now, in order to visualize how this data is going to be saved into the data store, we're going to need to use the HTTP service. So at the top, I'm going to get the HTTP service, and then I'm going to do print and I'm going to say DataStore.value, but I'm going to use the HTTP service to convert the value into JSON. So I'm going to use JSON encode, and this should show us what the value will look like inside of the data store. I can also print how many characters are used in the data store and the percentage that we've used in the data store. And to do this, all I need to do is say print and say data store, and I'm going to use the usage function. And this is going to return two numbers. The first number is how many characters are in the data store, and the second number is the percentage, 0 meaning 0% and 1 meaning 100%. So let's now run the game, and we can see that we're currently using 76 characters and a very small percentage of the maximum amount of characters we're allowed in the data store. And we can see the JSON code of how it's going to be saved in the data store. Now, before I show you how to compress the data store, I want to say that you should leave this as a last resort. And if you don't need to compress, that you should never enable compression, because if you enable compression, now it's going to consume more CPU in order to save the data store in every save interval. So to enable compression, after we have opened the data store, not before, we want to save a value into the metadata. So to do this, I'm going to say datastore.metadata.compress equals, and we're just going to set a empty table for now. If we set a empty table, it's just going to use all the default options for compression. So now that we've enabled compression, when we call the usage function, it should no longer pass the value of 76, and it should be less characters than it was before. But when we print the value, it's still going to print the exact same value, because the compressed value is stored in a different location inside of the data store object. So to get the compressed value, we're just going to change this to .compressed value. So we should now see the uncompressed value and the compressed value in this print. So let's now run the game again and see what happens. So we're currently at 76 characters, and it got reduced down to 58 characters. And here we can see what the data looks like uncompressed, and here we can see what the data looks like while it's compressed. So the first thing we'll notice is that strings of the keys don't get compressed, and the string of the value also doesn't get compressed. And if we look at the numbers, we can see that 1, 2, 3, 4 was compressed down to 2 characters of equals E, and 4, 3, 2, 1 was compressed down to 2 characters of 5 and Q, and this large number was compressed down to 1, 2, 3, 4, 5 characters. And we can see that the true was compressed down to 1 character. And here we can see this large number over here, and this was also compressed down to 1, 2, 3, 4, 5 characters. Let's now go over some of the options for compression. So if we, inside this table, we can set a key of level equals, and the default value is 2. But if we want to, we can reduce it down to 1. Now this won't compress arrays as much as level 2, but what it does allow is for us to have mixed arrays. So if I now run the game again, now we should see that it saves the keys of the array as well. So we can see key 1 is equal to this value, key 2 is equal to this value, key 3 is equal to this value, and we can also see that the character count increased. And the reason why this is good is because now we can have a mixed array. So I can put, for instance, test and have this equal 3. And if I run again, so now we should see that we have key 1, key 2, key 3, and key 4, and we also have the test key which is equal to 3. The next option we have for compression is decimals. So by default, decimals is equal to the value of 3. And what that means is if we have a number with a load of decimals, it's only going to save the first 3 decimals. And these values over here are going to get lost. But we can change this value. For instance, if we change it to 4, now it's going to save 4 decimals. But in turn, by increasing this number, it's going to consume more characters in your data store. And finally, the last option for compression is safety. And by default, this is equal to true. So what safety does is, if we look at the strings in our compressed data, at the end of a string, you'll see a space. But this is not actually a space character. This is the delete character. And this character indicates that this is the end of this string. So what can happen is, if we use this delete character in any of our strings, for instance, let's make a key called bad equals, and if I copy this delete character from here into here, so now we have a delete character in our string, this is going to break the data store from compression correctly, because it's going to think that this is the end of the string when it's not. So what safety is going to do is going to scan your strings and replace the delete character with a space. So now this is going to work correctly, because safety is going to prevent us from having the delete character in any of our strings. Now you may think that, well, I'm never going to use a delete character, so I don't need safety. And by turning safety off, it will reduce the amount of CPU the module will use when saving a compressed value. But we have to remember that in remote events, the client is able to send the delete character. So if you're accepting strings from remote events, we need to make sure that the client will never send us a delete character. So what that means is, if you're saving strings sent from the client, it's always recommended to keep safety on to prevent clients from sending us the delete character. But if you're never accepting strings from the client, then it's safe to turn this to false. Thank you for watching the video, and if you have any questions, feel free to leave a comment down below, or you can join the Discord channel in the description.